In this video we're going to have a little look at magnesium and some of the other group 2 metals and how they're used, some of them in particular in this video, the hydroxides of those as well. So firstly, it's a little bit of a one-off really, we're having a look at the use of magnesium in the extraction of titanium, and it's important to know about this because titanium is a very useful metal used in lots of different particular industries. Unfortunately, it's very difficult to extract from its ores because reduction of carbon produces very brittle titanium carbide. So in order to avoid using that process, they first take titanium oxide and they react it with chlorine and carbon to form titanium tetrachloride. There's the equation for that: titanium oxide plus your chlorine, 2 carbons, giving your titanium tetrachloride and carbon monoxide. Then your magnesium comes in. The titanium chloride is then reduced with magnesium to produce a titanium metal that we want to use. So that's the second equation there. So 2 important equations. They are on the specification, but just a small reason really. As I say, it's just one of the uses for a particular group 2 magnesium, which is very useful. Now we're moving on to the group 2 hydroxides, and you've met a few hydroxides before, and these are just the same. So as they're alkalis, they will react with acids. So we'll do a couple of examples of those. So M just represents any of the group 2 metals there. So you've got the hydroxide, group 2 metal, plus HCl. Acid plus base gives salt plus water, so you'd have your metal chloride plus water. And that's just a second example using a different acid. Now we're going to have a look at the group 2 hydroxides and in particular their solubility. Your teacher may have demonstrated this, or you may have watched a video about the solubilities. So some of this you may be able to fill in already. So we start with magnesium hydroxide. Remember, this is one that's sparingly soluble, so we'll only have a pH of about 8, because it's not as soluble as the other alkali ones. As you come down the group, the hydroxides increase in their solubility. If it's more soluble in solution, the pH will rise. Coming down the group to barium hydroxide. Barium hydroxide is completely soluble, so it's all in solution, therefore the solution is high pH 13. So as you can see, as you come down the group, the solubility of the group 2 hydroxides increases. If there's more of the hydroxide in solution, then the pH will increase as you come down the group. Because indeed they are alkaline solutions and solids, then they can help with a number of uses. As medication, magnesium hydroxide is used in a number of indigestion remedies, things like Gaviscon, etc. So these are used to neutralise stomach acid. Calcium hydroxide can also be used in agriculture. You can put it onto acidic soils and it will neutralise as acids within the soils. So now we'll briefly look at the sulfates, the group 2 sulfates. Again, you might have seen a demonstration or a video around the actual observations here. So with the sulfates, it's the opposite trend to what it was with the hydroxides. So the sulfates, the magnesium sulfate is the most soluble now at the top of the group, whereas barium sulfate is insoluble at the bottom of the group, and solubility decreases down the group. You make sure you use the words appropriately, so something's either soluble like magnesium sulfate completely, sparingly soluble like calcium sulfates, or insoluble completely